Alright, our standard today is MA for mathematics. 9-12, 9th through 12th grade mathematics. DP is data, analysis, and probability. So this is analyzing data today. 2.8. So everybody's got the date and the assignment right now. I'm going to switch the screen. I'm going to show the whole standard because I want you to write the whole thing. This is what it looks like in your book. It's the second one here. Data analysis and probability. So there's some fancy lingo here. It says fit a quadratic function to bivariate. That means there's two variables, x and y. Bivariate. Numerical data that suggests a quadratic association. So the word suggest is interesting. It's not an exact quadratic association. It is suggested. So what we're talking about today is a scatter plot, and we did scatter plots before, and we drew a line of fit. But today our scatter plots are not linear. We're looking at a scatter plot like this, where the line of fit would be quadratic. Okay, it suggests a quadratic relationship or a parabolic relationship. Yeah. So we're supposed to interpret the intercepts or the vertex. We use a model to solve real-world problems in terms of the context of the data. So the first problem we're going to do today is about the thickness of ice and how much weight that ice can hold. Who do you think cares about the thickness of ice and how much weight it can hold? Humans. But actually, the data is given in tons. Lewis, why would data about weight on ice be given in tons and not pounds? An ice box? Yeah, ice box. So what do we measure in tons? Machinery, semi trucks. Do semi trucks drive over ice? They actually do. There's places in Alaska, North Canada. I'm sure there's a lot of places in Europe, in Russia, where in the summer they get their supplies by boat. In the winter, they wait for the ice to get thick enough, and a semi truck drives right over it. Okay, so this is more like civil engineering, thinking about what bridges are around and how humans are going to get goods to and from places. Okay. All of our problems, the two problems yesterday for the assignment, and all of our problems today are real life data. I hope you're thinking about it. I hope you're thinking about what's this data from, who collected it, do I think this data is real, who uses it, think about the people, the scientists who are actually using this information. Has everybody had enough time to write this long standard down? All right, we're going to go straight into classwork. So flip to 156 now. And here it is. Here's our ice problem. This table shows the results of an experiment testing the maximum weight in tons supported by ice x inches thick. Write a function that models the data. And then we're going to use the function to state how much weight can be supported by ice that is 22 inches thick. So look, a foot of ice can hold 3.4 tons. How much does a semi-truck weigh? Or a tractor, or a snowplow? Maybe it's just a snowplow needs to get across the ice. How much do you think? Because I don't know. Yeah, a semi-truck's a couple tons. Sometimes you see on small bridges, there'll be a sign that says bridge will not support over 2 tons. And that semi-truck has to turn around, go back, and find a different road. So civil engineers document the type of steel they use, so that they know just which semi trucks can go over their bridges, because some of them small ones they can't support a lot of weight. All right, guys. I want you to pretend that this 0, -5 was typed here. Okay, just pretend that was typed in there. We're not gonna do that. It's crossed out. It's crossed out. All right, so we're gonna go through the steps from yesterday. So first we wrote the standard form model. That was the first thing. This is what we're plugging into. Our goal is to write this equation and to find A and B. So get your goal in your head. How are we gonna find A and B? What do you do first? What number do we plug in first from yesterday? The intercept. C. Good job. So my next step is to put the -5 in for C. The y-intercept always has x equals 0. If you weren't given that, like if I hadn't written that in, then we would be totally reliant on our calculator right now. Because you can do a system with 3 unknowns, but that's not algebra 2. So anyway, you got to have C to go through this particular process. All right, number 3, step 3 from yesterday. This was the hard part. This is what's brand new to you. You haven't done before. What do we do next? We're going to pick 2 ordered pairs to plug in. Everybody, let's plug in the same thing. Let's plug in 14, 7.6. That'll be our first ordered pair. That's our x, comma, y. And let's do 24, 40.6. That'll be our second ordered pair, x, comma, y. So the reason I said you really need a calculator is because these decimals, these numbers are more difficult than yesterday's numbers because it is real data. Okay, so we're going to make 2 equations using 2 points. So number 1, you get your x and your y. I'm going to pause just so everybody in the room has a chance to ask somebody what the heck this is. All right, this is what you have to know. So I'm going to walk away. You can ask me or you can ask somebody next to you. Where'd that 7.6 come from? Where'd that 14 come from? Where'd the A come from? Where'd the B come from? Where'd the name? So ask somebody. If you can't get that part, you're done. You can't get it. 0 points. You can't get this part. Ask the question. Ask the question. Pick up. Ask the question. Was anybody absent yesterday? Oh wow, very good. What are you waiting for? Yeah. So, you know where the -5 came from? Because it's the intercept. See the y-intercept. Okay. And then this is the x because it's ax squared dx, right? So I put the 14 in for x, and the y value up at 7.6, that's the y. So we're just plugging in x and y. Okay? Taylor, you got that? You're just plugging in x and y. Take your earbud out. Look at. We're into September, October. It's the earbud era. See who we can get. Okay, number 2. Once the earbuds start creeping out, the phones start creeping out with them. You can't change your song without your phone. Wow. Well, people don't. They like to search for their favorite one. Gotta let your brain rest. You guys are feeling it. Creating anxiety. Alright, so please let me know if you have a question so far. Then get your calculator. You're not gonna calculate with that donut in your hand. Put it away. We are doing math right now. Put it away. Do you have a calculator? How are you gonna calculate? You're gonna calculate without it? You guys, get the calculator out. Do these numbers yourself. Go to the media center and go check one out, okay? And let me know what happened. Media center. See if you can check one out. Between classes, during lunch, maybe tomorrow during your fitness class, you can go get a calculator, ask your coach. I'm sure your coach values math there. I'm talking about first period. Yeah, first period. Say, hey, I've been here. Can you go get some of your calculator for math class? Have your coach ask me about that. I love talking. Oh, right. Yeah. So, what I'm gonna do, I'm gonna multiply the top by -24, and I'm gonna multiply the bottom by 14. 0.5. Nice, good job. All right, here I go. 14 squared. So 7.6 equals 196a plus 14b minus 5. Ask a question. Where did you get 196? Why did you switch 14 and b? I just rewrote it because technically we put our coefficient in front of our variable. I just rewrote it. What is 24 squared? Oh, 576. Great. 24b minus 5. All right, I'm this far. Who else is this far? Who else has a question? Let's see a thumbs up if you got to the purple and green part where I'm at. Okay, we have to make opposites. So I've already had someone ask me, how do you make opposites here? I've already had someone answer, but I'm going to wait for the rest of y'all. Think about it for a minute. How do we make opposites? We do. We need a negative number. You're right. I'm thinking, does 196 go into 576? So I checked in my calculator. It doesn't work. And well, 14 times 2 is 28. So I tried 14 times 3, 4, 5, and just to see if I could find anything in common. I couldn't. I'm not finding a number to make these opposites. Do you have a strategy back there? Yeah. So if you need to make opposites and it's not clear, like yesterday's numbers, it was clear. Oh, 2 will work, 3 will work. These numbers are more difficult. I'm going to do the whole top by 24, and then I'll do the whole bottom by the 14, and that'll make them opposites. So if the numbers are too difficult, just multiply them by each other. Yes, -24. Yep. Well, I'm going to keep the 14 positive because I only want one to be negative. So the top's going to get the 24, the bottom's going to get the 14, and if our math comes out right, we'll have opposites. It's also been pointing out that if you divide it by 2, it also works because they have a common factor of 2. So if you want to try a smaller number, you could try 12 and 7, which totally tracks. It's really good strategy. All right, so now we have to distribute through. Now, if you're not practicing all these calculations by hand, on the day of your test, you're going to run out of time because you're going to look at your calculator like it's something you don't know and love. You should know and love your buttons on your calculator like you know your phone. Can you text without looking at it? Can you click a button without looking at it? That's how good you should know your calculator. So if you're watching me, you're going to run out of time because you're not practicing the muscle memory of the calculator. What? I mean, that's a good question. I can text without looking. So. All right, this still has an A. I mean, I'm really fast on it. I'm not running out of time compared to my peers, but that's why I'm right here. 8064A. Michelle? Anybody else find A? You can compare it with him? Come on. You found A? Yeah. You found it. Compare it with him. All right, sure enough, I did my distributions and I ended up with opposite B's. So my strategy works, multiplying the top by the bottom number and vice versa. Look at your numbers and see, are we matching up all right? You got the same numbers I do. And ask a question. Yeah. Thank you. Positive 120. The 70 is still negative though. Good. Who else has a question, observation, correction? Okay, I'm going to add down. You found it? What are you going to do to find B now? All right, we found A. You never stop there. You got to go ahead and find B. Yeah. Okay, that's good. Isn't it 110? Isn't it 110? Plug A equals 0.1 into original equation to find B. So I'm going to take this 0.1 and I'm going to all the way to this top equation, and that's going to help me find B. But please ask me if you weren't able to get to 0.1. Ask a question. Is anybody, let's see a thumbs up if you're working at finding B right now. Okay, just want to make sure I'm not too far ahead of you guys. Is anybody in here still have that chapter 2 book page? Yeah, because we're plugged into that form. 0.5? Anybody? Negative 0.5. All right, you plug in 0.1 and you get negative 0.5 out. Remember our goal was to have a full complete equation, so now we can write it. It's 0.1x squared minus 0.5x minus 5. Anything representing how much weight ice can hold dependent on its thickness. You plug in some thickness of ice and we'll know how much weight it can hold. So that's informative for building bridges. Getting goods to humans in polar bears in need. Scientists in the Arctic. So many good Arctic movies. Who's got a question? You didn't get negative 0.5 out. You're not sure why. Happy to look at your work and check your numbers. All right. What I did not get to yesterday was actually using the equation. So after you write the equation and you get your goal, a problem will tell you to then use the equation to make a prediction. So I want to move towards that. Use the equation after you write it. This says, and I highlighted it, how much weight can be supported by ice that is 22 inches thick? So I could make a guess because in the table it shows 20 inches and it shows 24 inches. So in the table I can say approximately, well I could show it as an inequality even, 22 inches of ice is going to hold between these two weights, right? But if I want to know more exactly, I'm going to take 22 and plug it in both of these x's, and that'll tell me the weight. All right, so after you write the equation, you will be asked to use that equation. So now plug in x equals 22, get an answer out, and use a complete sentence to describe the thickness of ice and the weight it can hold. The A and the B. Oh, we could have used any, but I knew it's better to use points that are spread out and looking at curves. Because if they're real close together, I think it gets a full picture. So I knew that, but that's great observation. Good question. That's something you don't learn right away. Over time, two separate points are better. Other good questions. All right, so we're plugging in 22 here and here. What are we gonna get? Is it Jerry? Did you do it? I'm working on that because you're, doing this other science too. You got an answer? Yeah, 32.4. Is that it? Dang, I don't have the work here. No, I'm gonna provide it, but you're also going to use your calculator to do it. Oh. The question in the problem says, how much weight can be supported by ice that is 22 inches thick? So I'm now using the equation that I wrote, and that's really the end goal. Like if we don't get to that, then we're kind of missing the whole point, is to have a useful equation. I got 42.4. I must be doing something wrong now. Too high. Oh, I have a 2 in one of my things instead of 22. Hey, you were like really gonna explain that. That's good. You're good. All right. So 32.4. So the equation predicts that ice 22 inches thick can hold 32.4 tons. You know what I think they do in the art? I think that they drill for oil. So can it hold an oil rig? Maybe that they set up in the freezing cold and they drill through the ice and they get down to that oil. Yeah. Put it all in your calculator. Not the y equals, but all of this in your calculator and hit enter once. It's really important you guys get good with technology because the scientists, the chemists, engineers out there, they're doing stuff by hand, but they're really putting a lot of things into software. They're really using technology a lot. So for that reason, we're going to do this problem all over again, and we're going to have our calculators do the work for us, okay? So I showed you guys how to do it with straight line scatter plots. Today we're doing it again with curved line scatter plots. So you hit the data in your calculator, and you input line 1 and line 2. We're doing the same problem all over again. You put the whole table in. Once it's done, you go to second data, and you go down to number 5, quadratic regression. I'm curious with those little tips, how many of you can move through the steps if you did it before? So in chapter 1 we did it, we're doing it again right now. We're letting the calculator do the math for us. On Desmos.com, hit the plus sign. Talk to the people around you. How do I use this calculator? We're doing that exact problem all over again. So I'm gonna put the table up here. I got 2. Enter. 4. Enter. I hope this is the problem. That's not, is it? That's a different question. No, don't put the 0, -5 in. Yo, don't put that in. Hit data, and a table should show up. You're gonna enter the table in. You have to be given that to do it by hand. This was designed for you to do it on a calculator, and I wanted to do it by hand with you, so I gave it to you. So pretend it's typed there. Okay. You can find it doing higher level math, but at this level, you're not supposed to do it without that. Okay, sorry guys. This is what we're putting into your table. 12, 14, 15, 18, 20. All the X's go in the first column. Libby. Okay.
I think it's just start with 12. We start with 14. How much points do we I think it's all. I don't know. That's start from 14.
You're entering all the X's and all the Y's. You answer that's for 1, 2, 3. Did anybody find A, B, and C on their calculator yet? Will you show him? Once you put it in your calculator, you hit second data and you scroll down to number 5 and hit enter. It does those. You gotta input this whole table. Yeah, if you're good at data entry, maybe you don't understand all the math that good, you can still go out there and get into the world of engineering. They need data. Analysts, data entry. They're not all doing calculations by hand. They really aren't. You're supposed to get numbers that look a lot like the numbers we did by hand. All right, there's Desmos. After you get the table in, it's Y1, squiggly sign. On the, it says it here. Yeah. Thank you. The squiggle. All right, there it is in Desmos. Let's take a look. Not what I expected, but kind of what I expected because of that -5. Okay. Alright, so they got A equals 0.0998. Now, if this was rounded, round up, round up, round up, that is A equals 0.1, which is exactly what we got by hand. That's kind of cool, right? They got B is negative point, round up, round up, round up, 0.5, which is exactly what we got hand. That is pretty cool. And then the C value is -5, exactly what we got by hand as well. It doesn't always work out that it comes out exact like that. Sometimes our numbers by hand are a little bit different than this, but this was a good example.
Depends on how many points resemble.
It depends on the coefficient, how tightly they are, how much spread there is in the data, and the standard deviation, which ASMAP 1 has been talking about standard deviation for like this whole time. I don't even know. Who's got a question? Yeah, did you all see your calculator pause? That's cool to see a calculator have to pause to do those calculations. Yeah, it froze. It froze for a second. It was calculating the deviation between every single one of those data points. It did a lot of math just then. All right, now you're gonna go to your homework yesterday, your assignment 1 and 2, and you are gonna check your answers. You can, but I'm gonna put them up there. No. So, a scatter plot can show. Scientists will look and see what it looks like. If my data looked like this, then I would be doing an exponential regression. If my data looks like a straight line, then I do a linear regression. If my data models a parabola, then I do the quad regression. Okay. This one, that's called exponential. That's like exponential. Okay. So more or less, you have to observe the relationship before you decide which one to do. I am going to answer your question still, but I'm going to put up the answer to number 1. All right, here's number 1. My question to you though is, did you use the equation? Everybody skip the last sentence. But I do want you to write the equation, use the equation. Hey, be quiet. You guys, let's see a thumbs up if you got 180x squared. Louis, did you get this 180x squared? Elijah, did you actually plug in to find out how much weight a 10 circumference rope can hold? So guys, if you didn't, it's gonna ask you a question at the end. Start paying attention to that. I'm doing that on your test. So you write this. It says how much. Part 2 is use the equation. How much weight can a circumference 10 rope hold? It's 18,000 pounds. When I talked about this last year, I was like, the circumference 10. That's a huge rope. I've never seen a rope that big. But that's a diameter 10. What's a circumference? This is like a circumference 10, the way around. Have you guys ever seen a rope this thick? Yeah. They probably use them on the ships. They maybe use them building things. We use chains. We use steel chains now. Or do we ever use ropes this thick anymore? Somebody somewhere does. I don't have ropes that thick in my house, but oh, to pull things. I think to pull things they use like the horses, and they use to pull things. They used to use some pretty thick ropes. Okay. Number 2. Did you guys have any success with number 2? If you wrote the equation, use the equation. It says after 1 second, how high is the balloon? 3 feet. You can still catch it. Did anybody get number 2 right? Let's talk about where you maybe went wrong. There's no point in getting wrong unless you learn from it. Mistakes are so important. Let's talk about where you went wrong. C was 5. A was negative 16. Did anybody get negative 16? On A.
I got negative 1.
Oh, then you were 1 unit off. Alright, on today's assignment. No, yeah, I'm gonna do them on tomorrow. They're all the same page. This is CY.
Okay, not C. Isn't it 5?
Yes, on number 2. Oh, I moved the 5 in my first step. I've been inconsistent about that. Sorry about that. Okay, on your assignment today, it's 3, 4, and 5. You guys are to do 3 of them using technology. You are to do 1 of them by hand as well. It's page 157. Number 3, 4, and 5. You can use technology. Do at least 1 by hand. But make sure that you answer the question with a complete sentence. Yep. That's the correlation coefficient. That tells us if our data is very spread out or if it's tight. Tight data is more accurate. Okay, so the closer to 1, the tighter, I believe. Oh, shoot. Hey, you guys need to write this down. Sit down. Shh. You guys sit down, sit down, sit down. Here's the intercepts.